One of the greatest thrills of attending an air show is the sound and feel of a high-performance Textron Lycoming engine as it thunders above the crowd. Hi, I'm John Nicholson. The engines on a high-performance or high-use aircraft are subject to punishing conditions. Cargo flying is a good example of high-use punishment, and that's why recently we visited Ameriflight in Burbank, California, the maintenance and operations base for over 170 cargo aircraft. This fleet of hard-working Lycoming engines logs thousands of domestic air miles each year. So how does Ameriflight achieve the best performance possible from these engines? Using Shell products is an important part of the answer. And during this video presentation, the professionals will show you how to achieve that optimal performance, or full TBO, from your new or replacement aircraft engine. So let's meet the experts. Ben Visser has been with Shell for over 30 years, working on the research and development of fuel and lubricants. He's the man who can answer the important questions about aviation lubricants. Paul McBride, who began his career at Textron Lycoming in 1963, is a third-generation employee. His knowledge of piston-driven aircraft engines is the result of years of hands-on experience. John Hazlett is the Vice President of Maintenance and Director of Operations at Ameriflight Incorporated. John's team has been able to achieve 99.87% reliability of their aircraft by adhering to the methods that will be demonstrated to you during this presentation. So, what are we hoping to learn from this video? Keep in mind that we'll cover three major areas of aircraft engine care: engine installation, startup and break-in, and maintenance and normal operating procedures.
So, as a pilot and new engine owner, you should get familiar with the procedures that will keep that engine flying in peak condition. That is, what to look for during the installation of your new or rebuilt engine, how to handle the initial startup and break-in, as well as executing proper maintenance and normal operating procedures. Let's focus on the installation. It would be so easy if we could just bolt the engine onto the airframe and place the aircraft back into service. But crucial elements need to be considered when installing a new or reconditioned engine. Instrumentation, baffles and seals, the oil cooler and air filter and their associated hoses are important parts of the overall system. Many high-use aircraft had their engines overhauled 2, 3, or more times, yet still retain the original gauges. For instance, a tachometer with a 5 to 10% error in calibration will greatly increase the load on the propeller and the engine bearings during operation. The cylinder head temperatures and exhaust gas temperatures are indicators of change in the engine. For high-performance engines, these indicators are critical when setting the mixture or monitoring the condition of the engine. So the tachometer, EGT, oil temp, and CHT gauges should be calibrated at this point and not overlooked. Be sure to use the most recent printing of the appropriate service bulletin. But what about oil temperature during operation? Is it too hot? Not hot enough? Ben Visser has the answer.
I bet you didn't know that a thermometer and a permanent marker can help you maintain an aircraft engine. But they can, and here's how it works. You need to make a reference mark at 180 degrees Fahrenheit on the face of your oil temperature gauge. This is a good target temperature for your engine oil. You should be aware that the typical green band on an oil gauge starts as low as 120 degrees and goes all the way up to 245 degrees. That's a pretty wide range. On most Lycoming engines, a cruising oil temperature significantly below 180 degrees won't boil off moisture present in the oil. This is especially true during a short flight. At the hottest point in a naturally aspirated engine, the temperature is about 50 degrees higher than the oil in the sump. So, if your oil temperature reading is only 150 degrees, the hottest oil in your engine is just 200 degrees. Well below the 212 degrees needed to boil off the water in the system formed from condensation. The result is water and acid buildup in the crankcase, which could lead to rust and corrosion. Moreover, if your aircraft is based in a humid climate and only flown occasionally, the chance of corrosion increases. We do not recommend that you ground run an inactive aircraft. A short ground run is insufficient to get the oil temperature to 180 degrees. Now, on a turbocharged engine, the highest oil temperature is usually 70 to 75 degrees higher than the sump. In this case, we want to keep the oil temperature down to around 180 degrees. This will help reduce engine wear and deposit buildup. That's where the thermometer and marker come in. Take your oil temperature sending unit and a reference thermometer and place them in a steel container filled with oil. With a hot plate, heat the oil to 180 degrees and mark your gauge. Even if your gauge has temperatures printed on the face, checking the accuracy is worth your time. So, make that mark at 180 degrees and extend the life of your engine.
We'll learn more about checking oil, oil pressure, and oil coolers later. But baffles and seals are the next item on our checklist. Let's see what Ben's cooking up now.
Here's a baffling problem that is often overlooked. It involves the baffles and seals of your aircraft. Both are critical to cooling your engine. When an aircraft is flying, air enters the cowling and creates static pressure above the engine. This pressure forces air down through the cylinders and across the oil cooler to lower pressure areas below and behind the engine. From here, the air is sent out through the flaps or other flaring openings. If your baffles are broken or misshaped, the deformity can increase the volume of air passing a particular cylinder or other area of your engine. Since the engine is dependent on a fixed amount of air, the result is a decrease of airflow to the other cylinders or to the oil cooler. Seals can create similar problems. If your seals aren't in good condition or improperly adjusted, they'll allow air to bleed out. This reduces the static pressure, which can increase temperatures. So what can you do? Have baffles checked while the engine is being serviced or before installing a new engine. The seals should be checked during periodic inspection. If cylinder temperatures still seem abnormally high to you, check all the seals for fit and condition. If the seals aren't soft and pliable, replace them. You can check the fit of your seals underneath the cowling. I like to look at the area where the seal and cowling rub together. You notice here on this side is one continuous line where it's rubbing, but along the top you can see that it is not a continuous area, and you can see where there are leaks. Here it's been rubbing. Here you can see where the air has been leaking out, which would reduce the static pressure above the engine. Inspect the holes at the rear of the cowling for excessive leakage as well. If your cylinder head temps still run hot, you may need to have the static air pressure above the engine checked during flight. This spec should be available from the airframe manufacturer. So keep your baffles and seals in good shape. It's a simple way to keep your cool.
And speaking of cool, an important focus point on your new engine is the oil cooler, hoses, and lines. If your engine is equipped with a remote oil cooler that hasn't been reconditioned during the overhaul, be sure to flush it out or replace it. This is critical if you had mechanical problems with the previous engine that could have left metal in the system. However, flushing alone may not get all the metal out. These metal particles could damage your new engine. One complete time between overhaul or TBO cycle is the normal life of many oil system hoses, so replace those as well. Remember that the oil cooler system must maintain oil temperatures within the specified limits shown in the applicable Textron Lycoming Operator's Manual. This is also a good time to check the air cleaner and associated hoses. If there are breaks or cracks, this can allow dirt to be sucked up into the engine, which greatly increases the wear rate. So what have we learned? New or reconditioned engines will perform better over a longer period of time with just a little help. Calibrate your instrumentation, check the baffles, and replace the seals if necessary. Flush out the oil cooler and hoses, and look over your air cleaner system. Replace those hoses if you notice excessive wear or cracks. And remember to consult the latest revision of the manufacturer's documents. Service instructions give us recommendations from the manufacturer. Service bulletins detail those points the manufacturer has deemed mandatory. Service letters contain useful supplemental information. And airworthiness directives are mandatory compliance regulations from the Federal Aviation Administration. Follow these guidelines at all points during the initial installation process of your new or rebuilt engine. After your Textron Lycoming engine is mounted, the next step is the initial startup and break-in of the engine. Here's Paul McBride of Textron Lycoming to discuss this important process with you.
Prior to shipping your new or rebuilt Lycoming engine, it has successfully passed a factory test run. Once you take delivery of your new engine, follow the initial startup procedure as detailed in the latest revision of the Textron Lycoming Service Instruction 1427. All Lycoming publications are now available on a CD-ROM. We strongly recommend that you review this publication prior to your initial startup and test flight. Some of the highlights of this publication include instructions that will ensure successful startup of your engine. Number 1, perform a ground run-up test to ensure proper oil pressure and check for oil and fuel leaks. The purpose of a ground run test performed in the aircraft is to assure that the engine meets all of the specifications, RPMs, manifold pressure, and fuel flow. Limit your test run to 3 minutes so that the temperature on the ground will not overheat and cause damage to the engine. Number 2, follow the recommended stated procedures for your first test flight, including the description of power settings and the duration for each setting. The purpose for engine break-in is to seat the piston rings and stabilize oil consumption. There isn't any difference or greater difficulty in seating the piston rings of a top overhaul engine versus a complete engine overhaul. You will note in the instruction that in order to seat the piston rings in a newly overhauled engine, you will want to cruise the aircraft at 65 to 75% power for the first 50 hours. So if you follow these simple steps, your oil consumption will stabilize and the piston rings will be properly seated. John Hazlett of Ameriflight Incorporated is a specialist in this process. If you follow these simple steps, your oil consumption will stabilize and the piston rings will be properly seated. John Hazlett of Ameriflight Incorporated is a specialist in this process.
Prior to your test flight, always do a thorough pre-flight as Paul recommended. Pay special attention to cowling security, oil level and dipstick security, spinner security, the things that have been off the airplane for the engine change. Engine test flights should be conducted in daytime VFR conditions. New or freshly overhauled piston engines tend to run hot, so you should minimize your ground running time. Remember that carelessness at this stage can cause expensive damage. Coordinate with ATC so you can start up, taxi out, run up, and take off without lengthy ground holds. If necessary to hold, turn the aircraft into the wind and idle at 1300 RPM for maximum cooling. At this point, you can make a normal takeoff. We've moved to the Ameriflight simulator to better illustrate the following steps. Keep in mind that the speeds and power settings that we're using are for a Piper Chieftain. Be sure you use what's appropriate for your airplane. After takeoff, if engine RPM is more than 100 above or below the red line on the tachometer, if manifold pressure goes above expected values on turbocharged engines, or if other abnormal conditions are seen, heard, or felt, reject the takeoff and have the problem checked out by maintenance personnel. As soon as you're above obstacles, accelerate to en route climb speed plus 10 knots for improved engine cooling. Then reduce to climb power at 1,000 feet above ground level, but continue to carry the extra speed. You'll also want to coordinate with air traffic control so that you can circle over the airport until reaching 3,000 feet above ground level. This will allow you to make an immediate return if you run into a problem. After reaching 3,000 feet above ground level, it's okay to leave the airport area if engine operation is normal. But remember, the objective is to put some time on the engine and verify its operation. Don't stray far from home. If you have a problem and have to land at another airport, it could get expensive. After reaching a suitable cruise altitude, set normal cruise power and mixture for turbocharged engines. For non-turbocharged engines, the procedure is slightly different. In this case, we want to set 24 inches of manifold pressure, 2,300 RPM, and 1 gallon per hour below climb fuel flow. Once every 5 minutes, cycle the new engine prop twice up to red line, back to 2200, and then reset 2300 RPM. After 20 minutes at this power setting, set normal cruise power and mixture. You should use high cruise power settings for break-in, 65 to 75% of rated power. You don't want to baby the engine at this point or the rings won't seat, but keep an eye on cylinder head and oil temperatures. Let's talk for a moment about the steps you'll want to take prior to landing. At Ameriflight, we've developed a stage cooling program designed to reduce the engine stress associated with power reductions. Your aircraft is equipped with an air-cooled engine that's pulling a tremendous amount of power. Unlike the liquid-cooled engine in your car, where you can put the accelerator to the floor and then release it with minimal or no damage, your air-cooled engine reacts very differently to sudden power reductions. Abruptly reducing the power in your aircraft engine causes the various engine parts to cool off and to contract. Since these parts are made out of different kinds of metal, they'll contract at different rates, and this may... Now, regulating power reductions in a naturally aspirated or unsupercharged engine is important, but it becomes crucial with the turbocharged engine. The concept behind Ameriflight's stage cooling program is to reduce power in small increments in order to give the engine a chance to catch up. Here's how it works. Begin your descent at 500 feet per minute at cruise power. Cause them to crack under the stress. Every 1 to 2 minutes, reduce manifold pressure in small increments, 2 to 4 inches. Keep repeating this process until you've reached the power setting for traffic pattern entry or final approach. Remember, our main concern here is to avoid abrupt, large power reductions, so in addition to a safe landing, you'll have a sound engine at the conclusion of your initial test flight.
Now that you've seen the initial startup and test flight procedures, Paul McBride will explain in more detail the oil recommendations for break-in of your Textron Lycoming engine, as specified in the latest revisions of Service Instruction 1427 and Service Instruction 1014.
Although mineral oil was necessary for the break-in process of the old channel or hard chrome cylinder, with the new steel nitrided cylinders on your Textron Lycoming engine, there are several new recommendations. For the correct oil for your application, always check the operator's manual and Service Instruction 1014. The latest revision of any document is important reference material because the recommendation may have changed since the original owner's manual was issued. All turbocharged engines must be broken in and operated using ashless dispersant oil only, like Aeroshell W100. Your new engine oil, whether mineral or ashless dispersant, should be changed after the first 5 hours of operation. The next change should occur at 20 hours and again after the next 25 hours. Each time you will clean the screens, cut the filter, and check for metal. We don't recommend performing oil analysis during the break-in process, as we usually see varied amounts of chrome and other metals during break-in. Our criteria tells us if oil consumption has stabilized after these 50 hours and there is no appreciable metal being produced, then your new engine is considered broken in. Ben Visser has more to add about oil and your newer rebuild engine. Ben Visser has more to add about oil and your newer rebuild engine.
What is the proper oil consumption for my engine? This is a question I get asked frequently at air shows. In terms of ranges, there really is no right answer. If I say that 6 to 10 hours per quart is good for a particular engine, a customer may complain that he only gets 5.5 hours per quart and conclude that his engine has a problem. This is not necessarily true, because each engine seeks its own level of oil consumption depending on several factors. Consumption rate depends on the type of oil you use, how the engine is broken in, the type of cylinders it has, and the type of flying the aircraft endures. For example, if the oil consumption is primarily past the rings, your rate can go down if you switch from a single grade oil like Aeroshell W100 to a multigrade oil such as Aeroshell 15W50. If the oil consumption is going past the intake guides or through leaks, your rate can go up if you switch from a single grade to a multigrade oil. The absolute level of oil consumption is not the critical factor. A significant change in the rate of oil consumption is what you want to look for. If your engine is using a quart of oil every 8 hours and suddenly begins to use a quart every 4 hours under the same type of service and conditions, you may want to consult your maintenance facility. Low oil consumption is not always better. This is especially true for large turbocharged engines which require a small amount of oil past the rings for proper seating during operation. Also, some aircraft will tend to throw out the first quart if you fill the sump to the maximum level. You may wish to operate a quart low. However, care should be taken when going on long cross countries to ensure adequate oil supply for the length of your trip.
Thanks, Ben. So we can conclude that proper engine startup and break-in are critical steps toward maximizing the operating life of your engine. Performing a ground run test and test flight, following the recommended procedures in Service Instruction 1427, and closely observing the recommendations for proper oil consumption will keep your engine in top working condition. Now that your engine has been placed into service, there are some specific normal operating procedures that will keep that engine operating at maximum performance. Operating at the correct temperature, using the correct fuel and oil, and following proper maintenance procedures are the key things to remember. Ben is ready to tell us about the right stuff when it comes to the normal operation of your aircraft.
Engine oil lubricates and keeps the engine clean. Everybody knows that, but actually engine oil performs 7 major functions. Lubrication to reduce surface-to-surface wear is the primary function of oil. Next, viscosity, or the fluid quality of the oil, acts to separate and protects moving parts. As a cooling medium, oil is essential in the efficient dissipation of heat within the engine. Oil's cleaning action washes away or suspends the products of combustion and other contaminants that reduce engine life. Corrosion protection is achieved through additives and helps protect your engine from moisture and the byproducts of combustion. And hydraulic action is the property of oil to transmit energy through a fluid. Now that you have a better understanding of what oil really does inside your engine, let's look at how useful air-oil separators can be to the process. Now that you have a better understanding of what oil really does inside your engine, let's look at how useful air-oil separators can be to the process.
Air-oil separators can be helpful when used correctly, but if not properly installed, they can act as a condensing unit, returning all the moisture from the crankcase blow-by back to the crankcase. This process can increase rust and corrosion during periods of inactivity. Whether your airplane has an air-oil separator or not, we recommend that if the plane is dormant for more than 4 months, use a preservative oil like Aeroshell Oil 2F to reduce rust and corrosion. Crankcase oil heaters heat the oil prior to engine startup. If there is moisture present in the oil and the heater is left on all the time, increased vaporization of moisture from the oil will be the result. The water will condense on colder, non-heated engine parts, increasing the rust and corrosion tendency on these parts. If you have one of these units, we recommend you plug it in a few hours prior to flight time, or even the night before. Don't leave it on all the time. Also, use a preheater system that heats the engine as well as the oil.
For Textron Lycoming engines, we recommend using lubricating oils which conform to SAE J1966 and the former MIL L6082 straight mineral oil spec, or SAE J1899 and the former MIL L22851 ashless dispersant oil spec. The latest revision of Service Instruction 1014 states any brand name lubricating oil in accordance with these specifications is acceptable for use, and the proof of such conformity is the responsibility of the lubricating oil manufacturer. The ambient ground temperatures listed in this chart are meant only as a guide. Your personal judgment should be used when selecting the seasonal grade of oil to put into your engine. For example, if your aircraft is flown from or into a dramatically warmer or colder climate, only your personal judgment can determine what grade of oil to use, or when inlet temperatures approach the maximum allowable during operation, it's always a good idea to consider using a higher viscosity oil. Remember, most normally aspirated engines must be broken in on mineral oil during the first 50 hours of operation or until oil consumption has stabilized. All turbocharged engines must be broken in and operated with ashless dispersant oil only. See the manufacturer's publications for exceptions. For example, the 0320H and 0360E series. Laboratory tests indicate that in the first moment when an engine is started, there is insufficient residual oil between the rubbing parts, which can affect the service life of these components. Textron-Lycoming has evaluated an agent which, when added to the normal oil supply, deters scuffing under these conditions. The additive is LW16702 and is recommended as being essential for good engine operation. It can also be used in all types of aircraft engines except for installations that utilize a friction-type clutch with a common transmission engine oil system. See the latest revision of Service Instruction 1409 for additional information. This additive is also contained in Aeroshell Oil W15W50 and Aeroshell Oil W100 Plus, which meet the provisions of this service instruction. Review the special stipulations concerning the use of LW16702 for your particular engine series. LW16702 or an oil containing this additive is required for some engine models and recommended for others. You can find this information in the latest revisions of Service Bulletins 446 or 471. Service Bulletin 480 details Textron-Lycoming's recommendations for oil change intervals. We recommend a total of 4 months maximum between changes for both full flow filtration and pressure screen systems, or 25-hour interval oil change and screen cleaning for all engines employing a pressure screen system, or a 50-hour interval oil change and filter replacement for all engines using full flow filtration system unless otherwise noted as an exception in the latest revision of Service Bulletin 480. If all of these numbers seem confusing, all the more reason to pay close attention to your service bulletins.
Now let's take a look at the importance of an oil change and the role of oil analysis in an ongoing maintenance program. An oil change is still one of the cheapest, best maintenance buys going. Always change and inspect your filter and inspect your suction and pressure screen at each oil change. Another thing to remember about oil change intervals is not to go by the color of the oil in the dipstick. If the oil looks very black, that doesn't necessarily mean it's worn out. Conversely, if it's golden like honey, it doesn't mean you can go another 50 hours. Cut your filter apart and use a magnet to locate iron filings in your filter. An excess of iron or other metals could mean impending failure of internal parts. Also, conduct a visual inspection for non-metallic materials. Be sure to check that your safety wire has been reinstalled after a filter change. And please, avoid excessive skin contact with used oil. Remember, used oil contains hazardous substances such as lead, a byproduct of combustion. Don't worry if you have to mix brands or types of oil in an emergency. All mil-spec oils are compatible. Always change your oil before storing for the winter. Better yet, follow the engine manufacturer's recommendations for preservation. If you do oil analysis, do it on a regular basis. Take samples in a consistent manner. Do use the correct oil for your type of flying. When in doubt, refer to the engine manufacturer's recommendations. While oil analysis may not tell you everything about your engine condition, it's still a good tool to detect changes within your engine and should be considered as an important part of an ongoing preventative maintenance program. And finally, consider oil analysis as part of the research in buying a used aircraft. But remember, just one analysis may not tell you everything about the engine. Our final segment is designed to give you some tips to help you respond to a variety of other situations you may encounter during the normal operation of your new or rebuilt engine. John Hazlett is here to review some of these situations.
Situations like leaning, which, done properly, is beneficial for all engines and helps ensure that the oil gets up to the proper temperature. On the other hand, aggressive leaning, especially in turbocharged engines, can cause excessive temperatures and shorten the life of your engine. A word about temperature management. Common sense tells us to bring the engine up to the proper temperature before takeoff, and after landing, allow it to cool prior to shutdown. Your engine components are metallic, mainly aluminum and steel, and these metals expand and contract at different rates. Aluminum crankcases and pistons have a higher coefficient of thermal expansion than steel cylinders and crankshafts. Consequently, events like shock cooling your engine during a rapid descent can dramatically shorten the life of your engine parts. A word about inspections. Perform your 100-hour and annual inspections on time. Check that the seals and baffles are properly maintained. A word about trend monitoring. Some record keeping is mandated by law. As an aircraft owner or operator, some additional records will allow you to make important comparisons between flights, and these comparisons yield valuable information about changes in engine performance. So monitor the gauges after they're stabilized and record the readings. Compare those entries from flight to flight. Significant changes in these instrument readings are clues that engine problems may be developing. And a final word about oil. Change your oil on a regular basis. Remember that the less you fly, the more critical oil changes become. Check oil filters and screens for evidence of metal or other contamination, and don't rely on the oil's color to let you know when your oil is due for a change. Use winterization kits to prevent congealing in the oil cooler and to get the oil up to the proper temperature in cold weather. If you use an air oil separator, an acrobatic inverted system, or any additional external oil lines and plumbing, make sure the system is properly installed and does not act like a condensation unit that will return moisture to the crankcase. Remember, if you take good care of your engine, it will take good care of you.
All of us at Ameriflight, Textron Lycoming, and Shell Oil are proud of our contributions to the safety and enjoyment of general aviation. If you'd like more information about our products and their use in your aircraft, call the Shell Product Information Center or your Textron Lycoming representative. And thank you for watching.